Hello and welcome back to MechZone. Previously we have already finished with the major topic like casting, and today we shall be starting with yet another important topic in manufacturing and production technology, that is welding process. And this is the first lecture. The welding is covered in two modules. This is the first one. So let us start with the topic welding. So how welding is defined? Welding is defined as the process of joining. Actually here the joining can be either permanent or temporary. So welding is actually a permanent joining process, whereas if we are joining two dissimilar or similar materials with rivets, nuts or bolts which can be easily separated, then that becomes a temporary joining case. But welding here is a permanent joining and the components cannot be separated from each other. So two similar or dissimilar materials with or without the application of heat means heat may be applied or may not be applied, or with or without the application of pressure. Similarly, pressure may or may not be applied in case of welding. Now, the strength of the welding, after welding, the strength is definitely greater than that of the strength of base material. Heat and pressure are optional here. It may be applied or it may not be applied. And we see that the bond formation is taking place at the atomic level, and hence the strength in case of welding is higher as compared to the strength of the base material. Now, if we talk about the filler material, that the filler material is only used when the thickness is greater than 5 mm. Then only the filler material is used, and edge preparation is also required. But if the thickness of the materials which need material to be joined, then if it is less than 5 mm, then there is no need of any filler material. Simply by applying heat, the base material can be converted into the liquid state and then easily interacted with the atoms of the other material, and hence bond can be formed. And generally the composition of the filler material is same as that of the base material, that is for joining the similar types of materials. So now we come to the welding process. This is again a simple definition. Now we see sometimes a filler material is added to the molten pool to strengthen the weld. That I have already told you about the filler material. That filler material may have the same composition as that of the base material. And for joining two insoluble materials, generally we are using a filler material. So flux is actually converted into the slag, which prevents the gas defects, and we also provide the inert gas environment. So welding therefore becomes a process of localized coalescence. Coalescence means joining, which actually forms a permanent joint which is produced with or without the application of heat, or with or without the application of pressure. Pressure alone and with or without the application of filler materials can be used to join similar or dissimilar materials. And we see that the strength of the weld is definitely greater than the strength of the material or the base material. So this is a very important point which is to be noted here. So the different types of joints which can be created are butt joint can also be created. Then we have the lap joint can also be created. Okay, so these are the different types of joints which can be obtained by means of welding. Now we come to the different types of welding. First is the fusion welding. Fusion means we are using actually the heat as a source to melt the base metal and may add a filler material or metal. Solid state welding, it uses heat and pressure or pressure alone to join the metals. The temperature does not reach the melting point. Here the temperature is actually reaching the melting point, whereas here the temperature is not reaching the melting point. What is the actual physics behind the fusion welding is that a source of high density heat energy, because heat energy is quite high, we are reaching above the melting point, and the temperature of the surface enough to cause localized melting, what I discussed earlier, localized coalescence. If the heat density, that is power divided by the surface area, is too low, the heat is conducted away as fast as added and melting does not occur. So we have to reach above the melting point. So here is a quick classification of the different welding processes. You need to have an idea of each and every process because any of the processes may be asked, and this is very important. Classification: oxy-fuel gas welding, where we are using oxyacetylene, and pressure gas welding. And in the solid state we have forged welding, cold welding, friction welding, ultrasonic, explosive and roll welding. Arc welding, we are producing an arc. Shield metal arc welding, SMAW. Gas metal arc welding, GMAW, GAMAW. Pulsed arc, GAMAW P. Short circuit arc, then we have the electro gas, spray transfer, gas tungsten arc, this is very important, fluxed core arc welding, submerged arc welding, saw, this is also very important, plasma arc is important, stud welding is not important. Unique processes are thermit welding, laser beam welding, electro slag welding, flash welding, induction welding, then electron beam welding or EBW. Then in the resistance welding, we are utilizing the concept of friction to join two similar or dissimilar materials, that is resistance. Spot welding, we are actually applying or obtaining a welding at only a spot. Resistance. Seam welding, used to produce seamless tubes. Then projection welding. These are the different classifications of welding. Now here we have the arc welding. Arc welding, we use an electric arc to heat and melt the work material. So here heating and melting of the work material is actually taking place, and the arc can be either produced by AC supply or DC supply, both. So we can have AC arc welding and we can also have DC arc welding. However, we shall be discussing about the different types of polarities, that is the straight polarity and the reverse polarity also. In the straight polarity, the electrode is negative and workpiece is taken as positive, whereas in the reverse polarity, electrode is taken as positive and workpiece is taken as negative. In straight polarity, more heat is generated on the workpiece when as compared to the electrode. So here melting of the electrode is not taking place, only the heating of the workpiece. Majority of the heat is on the workpiece, whereas in case of the reverse polarity, the heat is mainly generated on the electrode as compared to the workpiece. Straight polarity is used for high thickness and high melting point materials. Why? Because here the heat is mainly generated on the workpiece, and reverse polarity is mainly used for low thickness and low melting point materials, because here the heat is not mainly generated on the workpiece, rather it is generated on the electrode. In case of the straight polarity, the depth of penetration is more, and in case of the reverse polarity, the depth of penetration is generally less, and welding deposition rate is less in straight polarity, whereas it is more in case of reverse polarity. Why? Because the melting of the electrode is taking place, which is eventually getting deposited, and welding speed is also less in case of straight polarity and it is more in case of reverse polarity. And but it's a very obvious fact that DC is more dangerous as compared to AC, because the constant magnitude and the direction of DC never changes, whereas in AC it may reduce to zero at a certain point because of its sinusoidal nature. And there is a phenomenon called as arc blow, which is limited to the DC arc welding, and we'll be studying about the arc blow in the upcoming slides. Next is the resistance welding. We are actually using the concept of friction, and because of the friction we are generating heat. In some cases, here especially in this case, we are not using the friction, rather we are using the concept of resistance, that is the resistance between the two plates is very high, and when electric current is applied, then I square RT Joule's law के accordingly heat generate होगी, and because of that heat the welding is taking place. The heat is generated by the resistance, that is by the formula I square RT, and electrical current at the welding point, and force is applied so as to firmly join these two plates or materials. Now in case of the laser welding, we are using a laser beam to melt the material, and it can be used for deep narrow welds. So since the laser has the capability to penetrate deep inside, therefore we use laser beam welding also. Diffusion means diffusion is the transfer of molecules or atoms from one material to the other. So we are using heat and pressure to join the metals by solid state diffusion. The temperature is less than half the melting point. This is a very important point that needs to be remembered, that here the temperature is less than half the melting point temperature. Now here in the friction welding, we are actually using the concept of friction. You can see in the diagram that one of the rods is actually undergoing a rotation, whereas the other is held fixed, and the rod is transverse in the forward direction such that it comes into contact with the stationary rod, and due to its contact, high friction between the two surfaces, large amount of heat is generated and it is pressed against this rod, and hence this joint is taking place, and after machining the surfaces can be made even. Now in the ultrasonic welding, we have a very high frequency transducer which is converting the electrical pulses into the ultrasonic vibrations, and because of that ultrasonic energy we are able to do welding. Uses rapid vibrations to break up the surface films and heat the films, allowing them to bond. So this is ultrasonic welding. Next is we have the electron beam welding. We are actually using a beam of electrons, and this process is carried out in a evacuated chamber. Why it is being carried out in an evacuated chamber is simply because if the air particles are present inside the chamber and the electrons collide with the air particles, so they may lose their most of the energy in the meanwhile, and hence they would not strike the target with the amount of energy that we assume them to be striking with. So in order to prevent the energy losses of the electrons, we are actually taking this setup in the vacuum chamber, and hence this process is carried out. It is a liquid state welding because there is actually the melting of material is taking place, and a very small, like keyhole, I have written keyhole type of weld is actually obtained. This is the anode and this is the cathode. Okay, so anode is the positive plate and cathode is the negative plate, you can see here. So this is called as electron beam welding. It can be used for both welding and cutting. It can also be used for cutting process. Thermionic emission is the process which is taking place. Thermionic emission we have already studied in our class 10th physics, where it says that whenever a surface or a material is heated, then the electrons which get energized, they are leaving the surface and they are coming out. So this process is called as thermionic emission. Therm means heat, ionic means ions, and emission means emission. Cathode and electrons both are negatively charged, so they will also undergo repulsion. High voltage between the anode and the cathode. There is a very high voltage which is applied here, about यहाँ आप देख सकते हैं 20 से लेके 200 किलो वोल्ट ऑफ voltage या potential difference is applied, and the electrons are highly accelerated. Okay, the electrons are highly accelerated and they are striking this plate or this medium or this you can say material with a very high energy. About the laser beam welding we have already discussed, but the type of laser that the full form of laser is, you must be knowing, we actually opt for this subject in the second year of BTech. It was an optional subject. So light amplification by stimulated emission of radiations is the full form for laser. So we can use carbon dioxide laser or ND-YAG. ND-YAG laser is a very commonly used laser. ND means niobium and YAG means yttrium, aluminium and garnet. So it is a type of material, so we can use ND-YAG laser also. If the if workpiece is highly reflective surface, then due to reflection concentration of heat is difficult. So the surface should not be highly reflecting so as to get a proper concentration of the laser beams which are required for welding. And it is, the lasers are emitted by coherent single phase emissions. इसमें हमने पढ़ा होगा कि inversion of population हो जाता है तो particles अपने lower state में आते हैं and they emit these laser light. So we are actually using a xenon lamp here. Okay, so xenon lamp is used and the laser beam is produced. So commonly used laser are carbon dioxide laser and ND-YAG laser. So next topic is braze welding. So in case of the braze welding, if edge preparation is possible, and we are actually using the concept of gravity force to enter the filler material in the downward direction, and this filler material is actually a combination of copper and tin, that is bronze. So bronze is actually used as a filler material, whereas flux we are using borax bead. So this is very important, and it may be asked in the 1 mark question that name the flux material which is used in the case of braze welding and name the filler material. So filler material is actually an alloy of copper, zinc, or copper and silver, or copper or aluminium, or copper or tin. It is known as spelter. Okay, so this can be used. Flux material used is borax. Please remember, flux and filler are two different materials. So application is producing of leak-proof joints in plumbing applications. तो जो हमारे प्लम्बर लोग होते हैं वो भी इसको यूज कर सकते हैं to produce leak-proof joints by means of braze welding. Next is the soldering. In case of the soldering, the filler material melting temperature is less than 427 degrees centigrade, and it is an alloy of lead and tin called as solder. So here the filler material is known as solder, and it is having a melting temperature less than 427 degrees centigrade. Flux material is used such as zinc chloride and ammonium chloride. So ZnCl2 and NH4Cl can be used as the flux material. So we have to definitely remember what are the different flux materials used for brazing as well as soldering. So applications are electrical and electronic circuit design. से हम लोग जब फर्स्ट ईयर में robotics में use करते थे, then we used to डू रोबोटिक वर्क, रोबोटिक्स का जो काम करते थे, देन वी हैव डेफिनेटली यूज दिस सोल्डरिंग आयरन हम लोग यूज करते थे. फैब्रिकेशन ऑफ प्रिंटेड सर्किट बोर्ड्स के लिए भी यूज हो सकता है फॉर हमारा सोल्डरिंग जो प्रोसेस है. ब्रेज वेल्डिंग क्या है? ब्रेज वेल्डिंग, इफ एच प्रिपरेशन इज पॉसिबल, फिलर मटेरियल इज एन अलॉय ऑफ कॉपर एंड टिन and it will be entering into the workpiece by means of gravity force जो मैंने आपको बता दिया. The strength of the joint is more. So braze welding में जो हमारी strength है, it is greater than brazing and it is then greater than soldering. तो सबसे हमारी जो डिक्रीज, सबसे कम स्ट्रेंथ आएगी वो हमारी सोल्डरिंग में आएगी और सबसे ज्यादा हमारा ब्रेज वेल्डिंग में हमें स्ट्रेंथ ऑब्टेन होगी. ये भी क्वेश्चन कई बार पूछा गया है कि अरेंज द स्ट्रेंथ ऑफ द वेल्डिंग जॉइंट इन केस ऑफ द फॉलोइंग 3 प्रोसेसेस. तो एक में था यही था, एक में था लेस देन का साइन लगा हुआ था, एक में इक्वल टू था, एक में यहाँ लेस आ गया. तो 4 ऑप्शंस इसमें से तोड़कर बनाए जा सकते हैं. अब जैसा कि मैंने आपको बताया कि कोई भी प्रोसेस कभी भी 100% एक्यूरेट नहीं हो सकता एंड इट हैज अ नंबर ऑफ डिफेक्ट्स. सो पहला डिफेक्ट है हमारा पोरोसिटी. पोरोसिटी क्या है? अगर आपका एटमॉस्फेरिक गैसेस, क्योंकि आपका जब वेल्डिंग जो वेल्ड बीड होता है, जहां पर वेल्डिंग का जो एक्शन होता है उसका टेम्परेचर आपको पता है बहुत ज्यादा हाई है. सो क्योंकि उसका टेम्परेचर हाई है तो इट मे रिएक्ट विद द एटमॉस्फेरिक गैसेस एंड द एटमॉस्फेरिक गैसेस मे गेट ट्रैप्ड देयर. सो द एटमॉस्फेरिक गैसेस विल बी ट्रैप्ड इनसाइड द लिक्विड मेटल एंड दे विल फॉर्म पोरोसिटी. So what is the remedy? Remedy is to provide sufficient amount of flux. We must provide sufficient amount of flux material and protect the liquid metal by providing shielding gas. So we are providing a shielding environment so as to prevent any reaction between the weld bead and the atmospheric gases. Next is the slag inclusion. Slag inclusion is mainly because of the improper cleaning or insufficient heat. Slag formed on the liquid metal will be trapped inside the joint. अगर हमने अपने surface को pre clean नहीं किया है then it may definitely lead to the slag inclusion. Include हो जाएगा slag उसी में. और इसका एक और रीजन क्या है? इनसफिशिएंट हीट. अगर आपने इनसफिशिएंट हीट प्रोवाइड की है, सफिशिएंट अमाउंट ऑफ हीट नहीं प्रोवाइड की है, तो भी हमारा स्लैग इंक्लूजन पॉसिबल हो सकता है एंड इट विल बी ट्रैप्ड इन द जॉइंट. रेमेडी क्या है? अगर आप जो भी सरफेस की वेल्डिंग करने जा रहे हैं उससे पहले सरफेस को प्रॉपर्ली क्लीन कर लीजिए एंड वी हैव टू प्रोवाइड सफिशिएंट अमाउंट ऑफ हीट आल्सो. नेक्स्ट इज द वेल्ड स्पैटर. स्पैटर का मतलब होता है छिटकना. जैसे मान लीजिए आप एक पैन में ऑयल लें, ऑयल को गर्म करने के बाद उसमें क्यूमन सीड्स या जीरा डालें, देन जीरा स्टार्ट्स टू स्पैटर. सो वही चीज होता है वेल्डिंग स्पैटर. ड्यू टू द मोर अमाउंट ऑफ लिक्विड मेटल इन द वेल्ड पूल, इफ द लिक्विड मेटल कैन बी स्प्लैश्ड ऑन टू द बेस, मतलब उसकी स्प्लैशिंग होने लगती है एंड इट विल प्रोड्यूस रफ सरफेस. डेफिनेटली जहां वो सॉलिडिफाई होगा वो सरफेस वहां पर रफ हो जाएगा. सो दिस इज एक्चुअली द वेल्ड स्पैटर. रेमेडी क्या है? वी हैव टू प्रोवाइड सफिशिएंट अमाउंट ऑफ हीट. सेलेक्ट द ऑप्टिमम वेल्डिंग स्पीड. वेल्डिंग स्पीड जो है, किस स्पीड में हमें वेल्डिंग करना है वो भी हमें ऑप्टिमम रखनी चाहिए. रिड्यूसिंग द आर्क ब्लो. एंड आर्क ब्लो वी सी दैट इट इज लिमिटेड टू ओनली डीसी आर्क वेल्डिंग. नेक्स्ट इज द लैक ऑफ फ्यूजन एंड पेनिट्रेशन. अगर आपकी सफिशिएंट अमाउंट ऑफ हीट नहीं है तो फिलर मटेरियल जो होगा आपका पूरी अच्छी तरीके से बेस मटेरियल के साथ फ्यूज नहीं हो पाएगा एंड दिस वुड लीड टू लैक ऑफ फ्यूजन एंड पेनिट्रेशन. तो रेमेडी क्या है? ऑप्टिमम वेल्डिंग स्पीड रखेंगे और सफिशिएंट अमाउंट ऑफ हीट को भी हमें प्रोवाइड करना पड़ेगा. So the next type of defect is cracks. क्योंकि due to the non-uniform cooling, if the internal stresses are developed in the weld bead, then it will lead to cracking. तो इसका क्या है? हमें यूनिफॉर्म कूलिंग एंड प्रोवाइड प्री हीटिंग एंड पोस्ट हीटिंग. तो मतलब वेल्डिंग करने से पहले भी प्रॉपर हीटिंग करनी चाहिए और वेल्डिंग करने के बाद भी अगर हम हीट कर रहे हैं then it will definitely lead to reduction of the cracks. So the next topic is अबाउट द वेल्ड बीड कैरेक्टरिस्टिक्स. देखिए यहाँ पर जो होता है ये वेल्डिंग होती है, ठीक है, और जैसे जैसे हम यहाँ से आगे बढ़ेंगे तो हमारा जो हीट ट्रांसफर है, हीट ट्रांसफर इज एक्चुअली गेटिंग रिड्यूस्ड. स्ट्रेंथ एंड द हार्ड हीट ट्रांसफर इन दिस डायरेक्शन इज गेटिंग रिड्यूस्ड. मतलब इस डायरेक्शन में हमारा हीट ट्रांसफर होगा बिकॉज यहाँ पर टेम्परेचर हाई है, यहाँ है टेम्परेचर लो, तो देयर इज अ नेगेटिव टेम्परेचर ग्रेडियंट फ्रॉम हियर टू हियर एंड ग्रेन ग्रोथ इज एक्चुअली टेकिंग प्लेस. What is there? Grain growth is actually taking place, so ductility is decreasing and strength and the hardness is increasing as we are moving away from the weld bead. This zone is called as the fusion zones. So fine grains which are formed, fine grains are brittle in nature, whereas equiaxed grains are soft and ductile. ये तो मैंने आपको कास्टिंग के लेक्चर में भी बता दिया था. So with this we come, so heat transfer जो है वो इस डायरेक्शन में होगा. Okay, HAZ मतलब heat affected zone. This is called as the heat affected zone. So with this we come to the end of this lecture. अभी एक लेक्चर हमारा और बचा है वेल्डिंग पे, तो आप लोग हमारे चैनल को देखते रहिए, हमें अपने वैल्यूबल फीडबैक्स देते रहिए और गेट की और अदर एग्जामिनेशंस की तैयारी हमारे साथ करते रहिए। अपनी प्रॉब्लम्स भी हमारे साथ शेयर करिए, हम लोग उसका आंसर करने के लिए वी ट्राई टू रिवर्ट बैक विद इन 24 to 48 आवर्स। तो आप हमारे चैनल के बारे में दूसरों को भी बताइए ताकि उन्हें भी बेनिफिट मिल सके, बिकॉज ऑन आवर चैनल एवरीथिंग इज अवेलेबल एब्सोल्युटली फॉर फ्री। कुछ भी कॉस्ट, आपको कोई भी तरीके का पैसा नहीं पे करना है। पूरा का पूरा स्टडी मटेरियल, पूरे वीडियो लेक्चर्स एंड दैट टू क्वालिटी वीडियो लेक्चर्स आपको प्रोवाइड किए जा रहे हैं ओनली फ्रॉम MechZone, and it is an initiative of the students, or rather postgraduate students from Motilal Nehru National Institute of Technology, Allahabad. So with this we come to the end of this lecture. In the next lecture we shall be continuing from here onwards. So thank you.